Good morning, my dear students. Today we will learn about the nanotechnology. In the last class I have explained about what to mean by nanotechnology. In the same way, further of nanotechnology and some of its related topics I am going to discuss here. So nanotechnology, which is an art and a science of manipulating matter at the nanoscale. At the nanoscale, we are going to manipulate what we call it as a nanotechnology. So nanotechnology is the study of making small microscopic things. It is an advance to the future here. So the figure what indicates here, that is the DNA strands, or it may be the carbon nanotubes. The figures what we are going to see here, the three figures, which are nothing but the nanoparticles or the nanotechnology which we are going to use. So what is a nanoscale here? So when we see the from first figure to the last, that is, we are going to have 1.27 into 10 raised to 7 meters. What we are going to see the bigger one, that is at the macro level, and 0.22 meter, which is at the 10 millions times smaller than the macro level, that is the micro level. And in the same way, 1 billion times smaller than the micro level, what we call it as the nano scale here. So that is 0.7 into 10 raised to minus 9 meter, which is the nanoscale here. We call this as a nanoscale here. So fluorescence that is made up of graphite material, graphene, what we call it as a graphene, where C60, which is of a smaller size particles, what we are having, that we call it as, in terms of a nanoscale, we are going to see that is 1 billion times smaller than the micro level. That is the nanoscale here. History of the nanotechnology, when we see from the 2000 years ago, that is sulfide nanocrystals used by Greeks and Romans to dye hair. That is, for the dyeing purpose, for the coloring for the hair, they are going to use, that is 2000 years ago, that is the sulfide nanocrystals. When we see the 1000 years ago, Middle Ages, that is gold nanoparticles of different sizes used to produce different colors in stained glass windows. That is different coating purpose they used to use this one. In 1974, nanotechnology, that is Taniguchi uses the term nanotechnology for the first time in 1974. And in 1981, IBM develops scanning tunneling microscope. This microscope evolved to allow the manipulation of individual atoms and molecules in the field of nanotechnology. In 1985, the Buckyball, that is scientists at Rice University and the University of Sussex, discover the C60, that is a graphene material. In 1991, carbon nanotubes were discovered by SWNT. So need for nanotechnology. Why we want this nanotechnology? What is the use of nanotechnology? That is, it allows the placement of small structures placed with precision, simplicity and low cost here. So leads to the economic growth, enhancement of national security, improves the quality of the products, leads to job creation here. So that is why we need the nanotechnology. So approaches of nanotechnology is by bottom-up approach and top-down approach we are having. So bottom-up approach is nothing but from the bottom, that is from the micro level, from the atomic level, from the molecular level, we are going to develop the material here. That from the base level, that is from the nanoscale to the material, we are going to develop. That is what we call it as bottom-up approach. And top-down approach is nothing but from larger particles, we are going to convert it to the nanoparticles, that we call it as a top-down process. So solid state, what we have learnt in the module 3, that is the solid state methods, that is ball milling process or mechanical milling, physical milling, chemical millings, all these are nothing but the top-down approach. That is from the metal, that is from the larger metal, we are going to convert that large metal to the smaller particles, that we call it as a top-down approach here. Nanoscale approach and fabrication. So what we mean by top-down approach? Creating smaller object using larger components, that is creating smaller object creating small object using larger object, that we call it as top-down approach, using principle of molecular recognition. And in that is what we call it as the solid state the systems what we are having, that is what we have seen in the model 3, that is ball milling process, mechanical milling, mechanical, or it may be the physical, chemical, whatever we have seen, those all nothing but the conversion of the larger material to the smaller material, that we call it as a top-down approach. In bottom-up approach, they arrange smaller components into more complex one, that is from smaller we are going to make it more complex, that is layer by layer self-assembly, layer by layer self-assembly of atoms or molecules, which results in the component, that is called as a bottom-up approach here. Nanotechnology applications, where we can use this nanotechnology applications, that is creating of nanotubes, that is carbon nanotubes. For the for making carbon nanotubes, we use the nanotechnology. For the medicine purpose, we use the nanotechnology. Information technology, nano robots, energy. So here we are having the different type of the application, nano filters, aerogel material. We are going to have a nano transistors, nano robots, all these, that is the targeted drug delivery, that is nothing but for the curing of cancer tumor, we are going to use these nanotechnology. Advantages, when we see an advantage of this, when we go with respect to the material, the nanotubes, we can create unique material. By using this nanotechnology, we can create a unique material and produce which are stronger, lighter, cheaper, durable, and precise materials can be manufactured. When we take an advantage of industrial, we are having computers can become 1 billion times faster and million times smaller when we use the nanotechnology. Automatic pollution cleanup, manufacturing at almost no cost. That is the advantages. In medical, when we take a medical advantages, end of illness, that is cancer, heart diseases can be cured by using nanotechnology. Universal immunity, the AIDS or flu, all these can be cured by using nanotechnology. Body, that is the sculpting, that is change your appearance, that is body sculpting, that is by using cosmetics. By using cosmetics, we can go for the change of the appearance here. That is what we are having the advantage. Nanomaterial, fluorines and carbon nanotubes. So Buckminster fluorines, this is, we call it as a fluorines, that is the atomic layer joining of atoms and atoms to create a fluorines here. So nanotubes, single-walled nanotubes and multi-walled nanotubes we are having. Single-walled nanotubes, these are the single-walled nanotubes, and these we call it as a multi-walled nanotubes. So these are having a single layer of the material, that is the nanomaterials which are used to create a nanotubes, and here we are having a multi-layers. We can do a multi-layers nanotubes. So carbon nanotubes, this rotating picture what we are going to see here, this is the rotating picture what we are going to see here, is actually a model of carbon nanotube, the strongest and stiffness material discovered till the date. So carbon nanotubes, also known as the bucket tubes, so or allotropes, these all are the allotropes of carbon with a cylindrical nanostructure. Nanotubes have been constructed with a length of diameter ratio of 1 billionth to 1 ratio. That is what we are having, the carbon nanotubes. So single-walled nanotubes, we have seen the single-walled nanotubes. So single-walled nanotubes have a diameter of close to 1 nanometer with a tube length that can be many millions of times longer. Many million times the longer we are going to have. The structure of the single-walled nanotube can be conceptualized by wrapping one atom thick layer of graphite called graphene into a seamless cylinders. The way the graphene sheet is wrapped is represented by a pair of indices called the Kreikel vector here. So single-walled nanotubes are an important variety of carbon nanotubes because they exhibit electrical properties here. So these nanotubes are having excellent electrical properties we are having. So these nanotubes, that is carbon nanotubes, which are used for which is having higher strength material, and it is having a thermal conductivity, it is having electrical conductivity. So these are used in the spacecrafts. Multi-walled nanotubes. Multi-walled nanotubes consist of multiple rolled layers, that is concentric tubes of graphite. There are two models of description of these multi-walled nanotubes. In the Russian doll model, sheets of graphite are arranged in concentric cylinders. In the parchment model, a single sheet of graphite is rolled in around itself, resembling a scroll of parchment or rolled newspaper. So like this, the concentric layers, multi-layers can be created by using the nanotubes. So torus, nanotorus is theoretically described as carbon nanotubes bent in a torus drought nut shape. In the drought nut shape, they are going to make these carbon nanotubes in terms of a bend. Nanotoric or a torus are predicted to have many unique properties, such as magnetic moments, which is the property of magnet that interact with an applied field to give a mechanical moment here. So nanobud. Carbon nanobuds are a newly created material combining two previously discovered allotropes of carbon. Carbon nanotubes and fluorines. These hybrid materials are useful properties of both the fluorines and carbon nanotubes. By using fluorines and carbon nanotubes, we are going to we can manufacture the nanobuds. Property of nanotubes. I have told you it is having high strength, high hardness, electrical and thermal properties it is having. So carbon nanotubes are the strongest and toughness material at discovered in terms of tensile strength and elastic modulus respectively. Hardness, when we talk about the hardness of compressed the single-walled nanotubes is 426 to 546 gigapascal, we can see, surpassing the value of 420 gigapascal for diamond. So it can cross the strength of the diamond. It is more harder than the diamond. Electrical property. In theory, the metallic nanotubes can carry an electric current density of 4 into 10 raised to 9 angstrom per centimeter square, which is more than 1000 times greater than metal such as copper. So it exhibits more electrical current when we compare with the copper. Thermal. All nanotubes are expected to be very good thermal conductors along the tube. The temperature stability of carbon nanotubes is estimated to be up to 2800 degrees Celsius in vacuum and about 750 degrees Celsius in air. So the thermal conductivity, the resistance to temperature exhibits up to 2800 degrees Celsius and 750 degrees Celsius in the air. So that is what it is having a capacity. So nanoparticles. Striking property of nanoparticles, that is a tremendous driving force for diffusion, semiconduction. That is tremendous driving force for diffusion. When we talk about nanoparticles, it is having a more driving force for diffusion, because when we are having in terms of atomic level or in the molecule level, it is having higher driving force. Semiconduction. When nanoparticles are used in semiconductors, in transistors, it is having a higher property of this. Quantization of electronic energy levels. That is, when these nanoparticles is used in terms for energy purpose. So the nanoparticle gives us more quantization of electronic energy levels here. Highly reactive. So when these nanoparticles are used in the mechanical electromechanical systems or nano electromechanical system, it exhibits a larger applications. So highly reactive, that is when this electric current or magnetic or it may be the physical contact of contacts with this nanoparticle, which results in the change in the dimension or else in the change in its shape. So that gives us highly reactive material it is. Implementation of nanotechnology. These has been implemented in nanosensors, nanocomputers, nanorods, iPods, nanogears. For all these, the nanotechnology has been implemented. So this is the nanogear what we are having. It is a nano robot repairing RBC, red blood corpuscles. So these the nano robots which are used for the curing of the cancer tumors, also for the removing the blockage of arteries. For these nano robots are used. Application of nanotubes. Solar cells developed at the New Jersey Institute of Technology using this carbon nanotube complex formed by a mixture of carbon nanotubes and carbon bulky balls. So solar cells have been manufactured. Ultra capacitors, transistors, paper batteries, other applications like in the what we call it as nano electromechanical systems, or else the macro electromechanical systems. For these nanotubes are being used. Application of nanotechnology in curing diseases like AIDS, to make new surgical devices, changing the untasteful medicine into tasteful. Nano products can be prepared at average sized homes. So it is having an advantages of less pollution, low production cost, mass production in food and consumables. Technology itself, nanotechnology itself, it is having an advantage. Electricity, war, for all these nanotechnologies are. The disadvantage of is health, mass production and war. So when we talk about the health, these nanomaterials, when it is circulated in the body, it gives us the reactive for the other parts. By this, the health, for the health, it is having a disadvantage. And when we talk about the mass production, by using nanomaterials, mass production is somewhat difficult, what we are having. And implication of nanotechnology, health and safety issues. Nanoparticles can cause serious illness or damage to human body. That is what we call it as an health. So untraceable destructive weapons of mass destruction. So when we talk about the health and safety issue, it is an untraceable destructive weapon of mass destruction. When we talk about social and political issues, create social strife through increasing wealth gap. Advisable of increasing scope of the technology creates a political dilemma. Environmental issues. Nano pollution is created by toxic waste from nanomaterial manufacturing, because we are going to have nanoparticles by it may be the tungsten, tantalum, silicon, the silver materials. These all gives us the toxic waste of when we go for manufacturing of these. Enhance global warming in long run. When we go for a long run, we are going to have a global warming. Grego. It is an hypothetical situation where self-replicating nanobots go out of control and consume all matter on Earth. So we are having the living form that is formed by billion of replicating nanobots gone mad here. So this is what we see here. That is when we go with respect to the living fog, or when we go with respect to the Grego, it is not in the control of us. That is what we are having. So this which indicates how the micro level, macro level and nano level which differs in terms of its size here. So these are the nanotubes which we are having. So the physicist, that is German physicist Richard Feynman, the ideas and concept behind nanoscience and nanotechnology started by this physicist, in which scientists would be able to manipulate and control individual atom and molecules. By using individual atoms and molecules, that nanotechnology what we are having. So when we talk about the different applications in terms of electronic biosensors, when possible for future application of molecular nanotechnology we are having. So that is a treatment of cancer, molecular imaging and therapy, that is by using chemotherapy we can go for curing by using nanotechnology. So that is what we are having here. So cancer diagnosed, targeting medication, homing on tumor. That is where exactly the tumor is there. On that they are going to have a treatment here, improved imaging, localized therapy, killing cancer cells by using nanotechnology. At exactly at the same point by the chemotherapy, they can go for curing of this cancer by using the nanotechnology. Energy application, we have talked about the energy application, that is a subfield of nanotechnology related to energy is nanofabrication, creating devices on the nanoscale smaller than 100 nanometers opens many doors for the development of a new ways to capture, store and transfer the energy. So this is a nanotechnology in memory and storage. So this is a 2 gigabyte hard drive. It weighs about 70 pounds. It was first used in 1980. Its cost at that time is ranged for $80,000 to $140,000 each. So 2 gigabytes in 1980 it is 80. When it goes on changing to 2010, it is only $1.05. So that is what we are having. 2 GB when it cost when 1980s to the 2010, it is only $1.05. Current research shows that by using nanotechnology, 1000 GB of memory can fit on the head of this pin, in the head of this pin. So whatever the pin we see on this head of the pin, we can place 1000 gigabytes of the memory. We can, that is 1000 gigabyte is nothing but a 1 terabyte that can be placed in this on the head of this pin. That is what we are having a nanotechnology. So nanotechnology for flexible electronics. Flexible electronics, only by manipulating the nanoscale structures of material can we create component with the necessary electronic properties, which can also be made flexible here. Industrial applications. The prominent application of nanotechnology in the household is self-cleaning or easy to clean. Surface on ceramics or glass. Nano-ceramic particles have improved the smoothness and heat resistance of common household equipment such as the flat iron. So the figure which indicates here nano coating, water droplets take up dirt particles. The water droplets, it takes the dirt particles can be removed. Nano coated surfaces. When we talk about the application of textile, used an engineered nanofibers already makes cloth water and stain repellent or wrinkle free, dirt repellent or the stain repellent, water repellent can be made by this. Textile with the nanotechnology, finish can be washed less frequently and at a lower temperature. Integrate tiny carbon particles, membranes and guarantee full surface protection from electrostatic charges for the wearer. When we talk about the military, so by using nanotechnology, the military would be able to create sensor systems that could detect biological agents. Nanoparticles can be injected into the material on soldier uniform to not only make the material more durable, but also to protect soldier from many different dangers such as high temperature, impacts and chemicals, antibacterial, antifungi. For all these, as well as for making a bulletproof jackets also, we can use these nanomaterials. So when we talk about the obstacles and hurdles, what I have talked about the disadvantages, that is mass production is a main, that is, and cost constraints we are having. Mass production cannot be done, it costs more here. Funding requires long-term investments, intellectual property issues, that is patent office, that is overhammered and underqualified here. At the conclusion of this topic, I would like to say that nanotechnology is a brand new technology that has just begun. It is a revolutionary science that will change all what we knew before. We were watching just in science fiction movies will in the near future be real here, and keeps us healthy because of nano robots that will repair every damage that we have in our body. So this is a new technology. What we see is healthy for the health purpose because of by using nano robots that will repair any damages that we have in our body. Nanotechnology will give us an abundant energy because it will transfer energy more effectively. Nanotechnology covers a lot of domains today and will cover a lot more in the near future. It is indefinitely big and will make a lot of inventions come true, like that is protection, for example, which scientists are working on today. That is what the conclusion we are having from the nanotechnology here. So these all are the references from where I have taken all these PPTs, the topics, whatever we are having. All these are from these reference sites which I have taken. The figures, the tables, all these are from this reference. So thank you.